On this day one of our circles unit, we're going to talk a little bit more about the parts of a circle, and we're going to introduce ideas of arc measure. Our goals today are to identify special segments and lines of a circle, demonstrate the knowledge of arc addition, and demonstrate the knowledge of relationships between congruent arcs, chords, and angles. This first part of this note sheet, I want you guys to fill out on your own. This is a review of day 0 video and notes. So go ahead, press pause, fill out these 9 problems, and unpause to check your answers. So please check your answers here and make note of anything that you get wrong, make corrections. These are really important that we understand what these terms are, and I can tell you that your quizzes and tests in this unit will start with a section identical to this, just a different diagram. So you have to make sure you understand these terms. Moving on, some additional information about the parts of a circle. One major rule, and this is something you probably already are aware of, is that all radii of one circle are congruent. So if I know that B is the center, then I know that segment CB and segment SB are congruent. Okay. So segment BC is congruent to segment BS, or I know that since segment CB or BC is 4, I know this is 4 as well. And that's true in this circle as well. B is the center of the circle, then I know these are congruent segments, and I have an algebra problem now. I know that 2x plus 1 is equal to 19. This is one algebra application you guys will be asked to solve. And when we solve this, subtract the 1 from both sides, divide both sides by 2, we find that x is equal to 9. Another rule that you guys are probably also aware of is that a diameter is equal to 2 radii. So if I know that CU is a radius and UB is a radius, CB is a diameter because it is a consistent, constant segment that goes through the center of the circle. SU is a radius, BU is a radius, but that doesn't make SB a diameter. It has to go through the center of the circle, and it's 2 radii. So if segment CB is 3x minus 1, I know the diameter here is 3x minus 1. Solve for x. The nice thing is I know all radii are congruent. All of those are congruent. If SU is 7, these are both 7 as well. And that means I can use segment addition. 3x minus 1, which is the diameter, is equal to 14, which is 2 radii. Add the 1 to both sides, divide by 3, and x is 5. So, moving on to some information about angles and arcs. A central angle is an angle whose vertex is the center of the circle. So I know in this case that angle CBA is a central angle. Angle CBA is a central angle because the vertex is B, the center of the circle. Okay, so I would name my central angle here, not with an M, just with angle CBA or ABC. And its measure is 40 degrees because I've been told it's 40 degrees. A minor arc. A minor arc is the same exact measure as its central angle. And we use a different symbol for an arc. The minor arc is just this outside part of the circle. Okay. So I would call this minor arc arc AC, which means I'm going to use AC because it starts at A and it ends at C, or CA, but I'm going to put an arc above it. Similar to a segment symbol, but now it has to have that curve. So my minor arc here is arc CA, and its measure is the exact same as the central angle. So if my central angle, angle CA or CBA, is 40 degrees, my minor arc that it intercepts is also 40 degrees. This arc is 40 degrees. A major arc measures more than 180 degrees, but less than 360 degrees. So the major arc is when my arc gets to be more than half of my circle. And a semicircle has exact measure of 180 degrees. In this diagram here, my major arc, and this is important, must be named with 3 points. So if I want to name my major arc, and I'll do this in red, it's this part here. This is more than half my circle. That's the major arc. Okay. And in this case, I would have to name it either arc CDA with the arc symbol or arc ADC. So it's got to be a start, where in what direction am I going, through what point, and where do I end. Okay, so my 2 start and end points need to be the ends here. Now, hopefully you all recognize an entire circle is 360 degrees. So if I know this part here is 40, I know the entire circle is 360. Subtract the 40, I have 320. That's how many degrees my major arc in this diagram is. What I did there was arc addition. It's the exact same idea as segment addition. Small plus small equals big. 320 in red plus 40 in blue equals 360, because the measure of a circle is 360 degrees. So I know that the measure of arc FO plus the measure of arc OR is equal to the measure of arc FR. Okay, because I start at F, go to O, O to R, segment addition, angle addition, arc addition. They're all exactly the same idea. In our example here, if I am given circle U, because I've told you that it's circle U, you can assume that U is the center, which is important because that's going to help us identify information as far as central angles, which help us identify minor arc measures. We know the measure of angle, so all the terminology and all the symbology here is really important. The measure of angle FUO. Start at F, go to U, go to O. I'm talking about this angle, is 20 degrees. And the measure of arc OR, start at O, go to R, but on the arc is 25 degrees. Find the measure of arc FR and the measure of arc FSR. So let's start with arc FR. Arc FR starts at F here, and it goes all the way over to R here. Well, we have to utilize the fact that we know central angle and arc are equal. That makes this 20 degrees. Now, if I want arc FR, it starts at 20, and it goes through 25. The measure of my arc FR is 45 degrees, arc addition. When they ask for the measure of arc FSR, that means start at F, go through S, so go in the direction of S, and then all the way to R and stop. That's my major arc. Arc FSR, if I know that arc FR is 45 degrees, then the measure of arc FSR is 360 minus that 45 degrees. This gives me the measure of my arc to be 315 degrees. So I want you guys to go ahead and practice this. First, 2 that are not terribly challenging. Find X in both of these diagrams. Go ahead, press pause, give those 2 a try, then unpause. So number 1, X is 130 degrees. 130 degrees is my central angle. X is that minor arc that is intercepted by that central angle. Central angle, minor arc are equal. Number 2 is a little bit more challenging, but if I know that this major arc is 250, which is what the label means, then I know the minor arc is 110 because of arc addition. Minor arc, central angle, are congruent. Having gone through those two, go ahead and give numbers 3 and 4 a try now, please. So the trickiest part here is recognizing what arc they're looking for. If they want arc CUS, start at C, go through U, and then through S. CUS, I got my minor arc and my central angle, and then it's arc addition. And in number 4, it's about an angle measure, so again, pay attention to the terminology. If that's angle MTV, start at M, go to T, then to V, I formed this angle. 22 means the central angle is 22, arc of 77 means the central angle is 77, now it's angle addition. Number 5 is much closer to what your test and quiz is going to look like. We will have problems very similar to this on your test and quiz. The major hint here is, what does a semicircle measure? So the major idea here is recognition that a semicircle is 180 degrees. With that clue, go ahead and see if you can label all the things accurately here, and then solve for X, arc DAB, and arc BC. So with everything labeled accurately here, and now recognition that arc ADC is a semicircle, that's 180 degrees, I can use arc addition to add those two arcs together to solve for X. In doing so, we find X is 25, and now I can find the measure of my other angles and my arcs. So what I've done first is I've found the 3 arcs that they gave me. The measure of arc AB is 123 degrees, the measure of arc AD is 105 degrees, the measure of arc CD is 105 degrees. Since they want the measure of arc DAB, that means start at D, through A to B. Well, that's arc AD and arc AB. I have to do arc addition, add my 2 arc measures, and I have a 228 degree arc. To find arc BC, I added all 3 of these arcs together for 303 degrees. That takes me from B all the way around to C in the opposite direction, leaves me with just this. Well, the 303 plus whatever BC is 360. That's the whole circle. So I subtract 360, I get 57 degrees.